guys. So today we keep solving our math GRE 9367 form. 9367 form. Yeah. So we solved the 40. Okay. We solved 42. Okay. Okay. 42. Okay. What is the greatest value for b for any real function satisfy the property that must also satisfy the f1 smaller than 5? So basically, f is infinite differentiable, and the first derivative, second derivative, and the value f0, and that the third derivative is bounded. Okay, so this is the Taylor's theorem. Okay, arrow term. Okay, so basically, if f is infinite differentiable, then basically you can use the Taylor expansion to approximate, to do the approximation. Okay. And what we need to know is we need to know the k term arrow bound. So theorem say that the f minus up to k. So that means we only do a Taylor expansion to up to k term. The arrow will bounded by the next term. Will bounded by the next term. So basically we're bounded by the next term, right? We're bounded by this term. Important fact is that since x, usually when we use this, we are assuming that x is inside some closed interval. So basically, this term can be written as some bounded, some b minus a to n plus 1 power and n plus 1 factorial. It's bounded by this. So basically, it's bounded by the n plus 1 derivative. The maximum number, the maximum of this n plus 1 derivative. So since f is infinite differentiable, so n plus 1 is continuous. So basically there must be a maximum in the fn plus 1 term. So this is all we need to know. So all we just use this. Then we can solve the problem. Okay, so we leave it here. Probably we leave it here, and we try to use this. So basically, we are trying to find f of 1. So I choose a equals 0 and do the 0 this expansion. So we have this, and this, and the second, right, and the third. Up to second is enough. Okay, so f minus this one is f1 minus this is 1, this is 1, and this is 1. This is 2. So we have 1 plus 1 plus 1. So it's f1 minus 3. This must be bounded by the third derivative. So third derivative is bounded by b, which I don't know. And b to the third, and 3 factorial. And so we have f1 minus 3 is bounded by b over 6. And then we know that the maximum for f01 is 5, right? Because the question tell me that the f01 is less than 5. So since f1 is less than 5, so when f1 is 5, then this is 2. This 5 minus 3 is 2. So the greatest number for this is b divided by 6 is larger. Since f1 is okay, so maybe I should write down this. So basically f1 is smaller than 3 plus 6b, and need to be less than 5, right? So this must less than 5. So this is 3 plus, because we need to use this constraint to make this happen. So we have 6 divided by b is more than 2. No, b divided by 6. Sorry, b divided by 6. What I'm writing about. Sorry. So let me change this. Sorry about it. So this term tells you that f1 minus 3 is smaller than b over 6. So 3 plus 6, b over 6 need to be small, less or equal to 5, right? Because you need to use this b to constrain f of 1. So this tells you that b over 6 should less than 2. So b should less than 12. Should less than 12. So the answer is D. The answer is D. Somewhat complicated, but still can be done.